Hello students. In the last episodes, we discussed about sequences and series and also discussed about the arithmetic progression. In that, we have proved two formulae, one for the nth term of a sequence and also the sum of nth term of sequence. Today, we will be studying some more problems on the same. Suppose we have to find the sum of all the multiples of 7 between 100 and 1000. How should we proceed? The numbers are actually 105, 112 and so on up to 994. Thus, the first term is, that is A, is 105. The last term, that is 994. Here, our unknown is number of terms. N is not given to us. Suppose we assume it to be n. Then we also note that the last term is merely a plus n minus 1 d. Hence, we have 994 equals 105 plus n minus 1 times 7, which is d. We have 994 minus 105 plus 7 is equal to 7n. That gives 7n equal to 994 minus 105, that is 889 plus 7, 896, which implies n equal to 896 upon 7, which makes it 128. So we got the value of n equal to 128. This means that there are exactly 128 numbers between 100 and 1000 which are multiples of 7. Now we are required to find the sum of all these multiples. For this we write n by 2 plus 2a n minus 1 d, that equals 128 by 2. Our a was 105, so it is 2 times 105 plus n was 128, so it is 127 times d was 7. That equals 64 times 210 plus 889. That equals 64 times 1099, which equals 64 times 1100 minus 1. That equals 70400 minus 64, and that is 70336. Thus, 70336 is the sum of all the numbers between 100 and 1000 which are multiples of 7. Sometimes the series or sequence are not given directly, but sum of n terms is given in terms of n. For instance, suppose you are given Sn equal to 3n square plus 5n. Now at the first sight, neither we know A nor we know D. So usually we try to find first A and D and then proceed. Here, if you put n equal to 1, you get S1 is equal to 3 plus 5. It is nothing but the first term, that is A. Now put n equal to 2. You get S2 is equal to 3 times 4 plus 5 times 2, that is 22. And this is nothing but first term plus second term. Thus we have 2a plus d is equal to 22, while a is equal to 8. This gives d is equal to 6. And now we know both a and d, we can find the whole thing about the series. Now suppose in this series we have to find the term which gives 156. I mean that number term which makes 156. That is, we are given that Tm is 156 and we have to find m. Let us take a problem. Here Sn is given to be 3n square plus 5n and mth term is given to be 164. We have to find m. Now apparently the series is not given directly, because at the first sight neither we know A nor we know D, but we can find them easily. First of all, when we put n equal to 1, we get S1 is equal to 3 plus 5, that is 8. And S1 is same as the first term. So we got the value of A as 8. We put n is 2. We get S2 is equal to 3 times 2 square plus 5 times 2, that is 22. But S2 is actually first term plus second term, that is 8 plus 8 plus D, that is 16 plus D. But S2 was 22, hence D becomes 6. And now we know A and D. A was 8, D is 6. We can proceed as before. Now we have got Tm given to be 164. But by formula, Tm is A plus m minus 1 D. Hence, 164 is equal to 8 plus m minus 1 times 6. This implies 164 minus 8 is m minus 1 times 6. That is 156 is equal to m minus 1 times 6, implies 156 upon 6 is equal to m minus 1. Ultimately, we get m is equal to 127. That is m equal to 27. Now, the same problem can be done in one more way without finding A and D. We have Sn is equal to 3n square plus 5n. This means that Tm is Sm minus Sm minus 1. That gives 3m square plus 5m minus 3m minus 1 square plus 5m minus 1. This gives 3 times 2m minus 1 plus 5. That is 6m plus 2. But Tm was 164. This implies m is equal to 164 minus 2 upon 6, that is 27. Thus, we have seen there are two methods to attack problems in which nth term is given as a function of n. Our next problem contains another concept, namely arithmetic mean, or in short AM. The AM of two numbers is simply the average of these two. For instance, if A and B are two numbers, their arithmetic mean is A plus B by 2. Now, here is a problem. If A raised to power n plus B raised to power n upon A n minus 1 plus B n minus 1 is the AM of A and B, find n. So, we have A n plus B n upon A n minus 1 B n minus 1 is equal to A plus B by 2. This implies 2an plus 2bn is equal to an plus bn plus an minus 1b plus bn minus 1a. Again, it implies an plus bn equal to an minus 1b plus bn minus 1a. This implies an minus an minus 1b is equal to bn minus 1a minus bn. That implies an minus 1 times a minus b is equal to bn minus 1 times a minus b. That implies a minus b times an minus 1 bn minus 1 equal to 0. We can safely assume a is not b because a and b are distinct. This implies we can cancel a minus b both sides, so we get an minus 1 minus bn minus 1 equal to 0. That makes an minus 1 is equal to bn minus 1. Now, since we have assumed that a is not equal to b, so neither of them can be 0, because if b is 0, a is 0 and vice versa. So, neither b is 0 nor a is 0. So, we can write this as a upon b raised to power n minus 1 is equal to 1. Now, you know, any number raised to power 0 is 1 and no other index has this property. So, this implies n minus 1 is equal to 0, and this means n equal to 1. So, this gives the answer for the value of n in the given problem. So, students, today we discussed some problems on the summation of arithmetic progression, that is AP. We also introduced you the concept of arithmetic mean. In our next episode, we will further discuss some more type of problems in the summation of arithmetic series.